As the field of computer graphics continues to evolve, the demand to model more and more realistic-looking people increases, and nearly all people have hair. Our goal for this project was to learn and compare different ways to render realistic-looking human hair. The two methods we chose to focus on were the Kajia-K and Marshner models. The Kajia-K model represents the reflection of light off hairs in not just one direction, but off a cone formed by rotating the tangent vector of the hair by the surface normal of the intersection of the ray and the hair. To implement this, we use an open-source renderer called the Mitsuba renderer. Implementation of this incorporates a diffuse and a specular component. The diffuse part is mathematically equivalent to Blindfong. The specular component differs from Blindfong and is obtained by the equation shown. Here are our final results using the Kajia-K in tangent with aspects of a microfacet implementation.
The Marshner model considers the interaction of light and hair in a much more detailed way. The first part of the model has to deal with lobe selection. A lobe refers to the type of reflection that occurs off of the hair. There are three types that can occur. First is R, which is just a reflection off of the outside of the hair. Next is TT, which corresponds to double transmission. In this case, the light enters the hair and then exits out the other side. The third case is TRT, represents transmission, reflection, transmission. In this case, the light enters the hair, reflects off the inside of the hair, and then is transmitted back outside. After we have dealt with lobe selection, we have to calculate the outgoing vector. To do this, we split it into two angles, longitudinal and azimuthal. Here we can see how the longitudinal angle is affected by the three different types of lobe selection. The equation theta here is used to calculate the outgoing longitudinal angle, and the equation m is used to calculate weights. Here we can see how the three types of lobe selection affect the outgoing azimuthal angle. The equation phi here is used to calculate the outgoing azimuthal angle, and the equation a is used to calculate the weight.
Here are rendered images using the Marshner model. These first few images use lobe selection, longitudinal sampling, and the azimuthal sampling, but use tungsten's function for the final weight of the sample. These next few are entirely using our own code. We're extremely happy with the final results, but we had issues with noise that we were unable to fix completely. This noise has something to do with our calculation for the sample weights. Compared to the Kajia-K model, our Marshner implementation is a much more physically accurate representation of real human hair. Current models for rendering hair and fur still have a long way to go in order to appear truly photorealistic, but we're satisfied with the way our model turned out. Researching this topic was a lot of fun for us, and we're excited to learn about the future innovations in hair rendering.